Hey guys, so today we are going to discuss decimation and interpolation part 3, which is our continuation in the series of DSP, that is digital signal processing. And if you haven't watched part 1 and 2 of DSP, please do watch that, otherwise you won't be able to understand what's going on over here. So now let us first of all we will discuss a concept, and those guys who have been watching my videos for a long time, they know what to do when a concept comes. Star mark it in your notebook because these are very important. So now let us see. It may appear that decimation and interpolation are inverse operations, but this is not always true. So what do they mean by this statement? And what they are saying is that decimation and interpolation are inverse operations. It must have occurred to you also, because in decimation, that is I will represent it by D. In decimation we reduce the signal length, and in interpolation we increase the signal length. So basically they should be opposite of each other. But that is not always true. That is what they are trying to say. Let us understand that by looking at an example. Now suppose I have a signal xn, okay, and I have been asked to decimate it by 2. So this is how you represent decimation by 2. We simply write 2 in the numerator, and then after decimating it we have to do interpolation by 2, that is 2, and on doing that we will get xn, because if you interpolate this by 2, we will simply write 2 in the denominator, and this 2 and 2 will get cancelled, and we should simply get our original signal xn. Okay, so this is what we will get, our original signal xn. And now let us look at the second case. This was our first case, and now let us look at our second case. Now in our second case we have xn, the same signal, and first of all what we are going to do, we are doing is we are interpolating it by 2. Initially we decimated it by 2 first, but now we are going to interpolate it by 2, and we will get x of n by 2. This is how you represent interpolation. And now after interpolation we will be doing decimation. That is, on doing decimation you will get x of n. That is the original signal that we had over here. Now the question arises that which one of these signals will give us the correct form of the original signal xn, whether we should do decimation first or whether we should do interpolation first. Now in my second video I had discussed that we have to do interpolation first, whatever be the case, then only we will get the answer correctly. So this first case will not give us xn, as our original signal, but in the second case we will get this as the original signal xn. That is, the second case is correct and the first is wrong, which proves our above statement. That is, they are not inverse of each other, because we are doing interpolation first, then we are getting the correct answer, but if we are doing decimation first, then we are getting a wrong answer. So this is the step that you have to follow. If you were still unable to understand this, I am again going to explain it with an example. Now suppose I have a signal xn which is given by 1, 2, 6, 4 and 8, and the pointer is pointing at 1. The pointer's position is very important if you have to perform decimation and interpolation. So let us perform case number 1, where we are going to decimate it by 2. How do you represent decimation? We represent it by x of 2n. So now on doing decimation by 2, you will get the answer as 1, 6, 8. Now this must not be a problem, because you guys must have watched my previous videos. We simply take a leap of 1 because we are doing a decimation of 2. So on doing so we will get 1, 6 and 8. So this is our answer for decimation. So now what we are going to do is we are going to interpolate it by 2, as we had discussed earlier above. So now on interpolation, which is represented by x of 2n by 2, so this will get cancelled, and what we will get the answer as, it will come out to be 1. And keep in mind that we are doing linear interpolation, step interpolation. Okay, so what we will do, we will write gap 1 over here, then 2, then a gap over here, then 6, then a gap over here, then 4, then a gap over here, then 8, and then a gap over here. So what we will do is we are simply doing step interpolation. So we will write 1 over here, 2 over here, 6 over here, 4 over here, and 8 over here. So this is our final answer, which was supposed to be equal to xn. That was our original signal. But as you can see, our original signal was this. That is, xn is equal to 1, 2, 6, 4, 8. So this was our answer, but what have we got our answer to be? Like this, which is not correct. So as we can see, the first case will give us a wrong answer. So now let us see the second case. Let me change the color. Now in the second case, what we will do is, first of all, we will do interpolation. That is, we will write x of n by 2. That is, on doing interpolation of 2, what you will get the answer as 1, 1, 2, 2, 6, 6, 4, 4, 8, 8. So this is what you will get when you will be doing step interpolation. Keep in mind that we are doing step interpolation, and it will work for all the other interpolations as well. That is zero interpolation and linear interpolation, but we are doing step interpolation for the ease of understanding it. So now we have a pointer over here only. The pointer will remain where it is. Now what we will do is we will do decimation by 2 as discussed over here. So now on doing decimation, what you will get the answer as, it will come out to be 1, 2, 4, 6, 4, 8. Let me write it again. That is, on decimation you will get 1, 2, 6, 4 and 8. This will be your final answer. Now take a check whether it is equal to xn or not. Yes, it is. That is, this was our answer. This was the original signal, and this is our answer. And these two match each other. Hence, our second case will give us the correct answer. So this is how you will prove the above statement, that they are inverse of each other, but it may not always be true. So, and also keep in mind that the interpolation always has to be done first. No matter what you are doing, the interpolation part always has to be done first. So now let us move on to another concept. And you know what we have to do when we have a concept. You star mark it in your notebook. So please keep on making notes and write along with me. Pause your video, try it on your own and write it down. If you can't do it, then again watch the video, then do it, because these are the concepts which will be asked in the exam, and they are really important and they are really easy to score marks also. Now let us discuss another concept. Suppose we are given a signal, that is yn, and we have to find out x of n minus m by n. Now do not get afraid, this is simply we are doing interpolation, decimation and a little bit of delay. I'm assuming that you know what a delay is, because as you are doing signals and systems, so a delay is, suppose we have a signal x of n, and this is our signal. It is starting from 1, 0, and suppose if you have to do a delay of say m, we will write n minus m. So now what will happen is we will right shift the signal. That is, now our signal will start from m. Instead of 0, now our signal will start from m and it will continue as it was earlier. So this is what simply a delay means, and you should be familiar with what a delay is. Otherwise, you should watch my signal and system video. I have made a playlist on that also. So now what we will be doing is we will be discussing how to approach this type of question. Suppose we are given a question in which we have to find out a value like this which is given to us. So first of all, we will simply write xn. Then we will do in the first step, that is interpolation, as we discussed earlier, that the first step always has to be interpolation. And doing so you will get the answer as this, that is the interpolated part. And now secondly, you will do a delay of m, because we had this signal, and a delay of m will mean this, that is we are simply delaying it by m, that is we are moving the signal to the right. Okay, and now we will decimate it by 2. The decimation part always has to be done last. Okay, then only you will get the correct answer. Now we are decimating it by 2, and on doing so you will get this as your final answer, which is yn, which we had to find out. So you must have understood that what steps you have to follow. That is, first is interpolation, second is delay, and third is decimation. So now do not worry, let us understand this with the help of an example. Now suppose I have a signal, say xn, say xn is given to us, which is 2, 4, 6, 8. Okay, and the pointer is pointing at 6. Pointer's position is very important, keep that in mind. And now what we have to find out is yn is equal to x of n minus 0.5. Now this is what we have to find out. Now compare this question with the concept that we discussed earlier. Can I write this as x of n minus 1 by 2? Yes, it's the same thing. Here 1 represents capital M and here 2 represents capital N. So now what we will simply do is we will first of all write it as x of 2 n minus 1 by 2. Okay. And first of all what we will do is we will first of all perform the interpolation part which is given in the denominator, that is 2. So we will be writing it as x of n by 2. And over here we will be doing linear interpolation, which was the averaging part, the averaging concept that we discussed in part 1 of this video. If you haven't watched that, please watch that because you won't be able to understand it what we're doing over here. So now on doing so, that is on doing so linear interpolation, what first of all we will do is we will write 2 space 4 space 6 space 8, then a space over here again. Then we will write a over here, b over here, c over here and d over here. And in order to find a, b, c and d, you will write, we will be finding out the average, that is 2 plus 4 by 2. B will come out to be 4 plus 6 by 2. C will come out to be 6 plus 8 by 2. And D will come out to be 8 plus 0 by 2. So this is how you will find out A, B, C and D, which will come out to be 2, 3, 4, 5, 6, 7, 8, 4. That is, you will get 3 as A, and you will get 5 as B, and you will get 7 as C, and you will get 4 as D. So, and our pointer will remain at 8 over here. Okay, remain at 6 over here. Sorry, I'm very sorry. It will remain at 6 over here as it was given in the question. And now we will proceed with our question, that is, we will now perform the delay part. Now let us see the map. First of all, we performed interpolation and we found out the answer. Now we are going to perform delay. That is, here we have to perform a delay of 1. Over here you will see we are given that x of 2n minus 1 by 2. We have done the interpolation part, now we have to do the delay part. So first of all we will write our x as x of n minus 1 by 2. That is, we are now performing a delay on this equation that we have got, this signal that we have got. Now doing a delay of 1, what I discussed that we move our signal to the right. That is, we do a right shift. And on doing a right shift, all of our signals, all of our samples will move one space ahead. That is, 5 will replace 6, 6 will replace 7, 7 will replace 8 and 8 will replace 4. And 4 will move ahead. That is, on doing so you will get 2, 3, 4, 5, 6, 7, 8, 4. That is 2, 3, 4, 5, 6, 7 and 8. And now the pointer will be pointing at 5 because we have moved our signal one step ahead. So this is what you will get on doing a delay. So now on doing decimation, what we will do is, this is the last step, that is, now we have to decimate it. And decimate by how much? By 2, which was given in the question. So now we will write our signal as decimation 2n minus 1 by 2, which is the final answer that we have to find out. And on doing a decimation of 2, what we will do is we will take a jump of 1. That is, we will take a jump of 1 from 5, then we will again take a jump of 1 from 7. Similarly, we will take a jump of 1 to 3. Now we cannot take a jump because there is no other signal over here. So what we will get our final answer as, we will get 3, 5, 7 and 4. So guys, this is our answer that we had to find out using interpolation, decimation and delay. So the first step that we followed was the interpolation. That is, we performed linear interpolation. Then we performed a delay. Then we performed decimation. So this is our final answer. And guys, this is a very important concept. Please pause the video, try it on your own, make notes, and you simply have to write whatever I'm writing on the screen over here. You do not have to worry whether we are missing any concept or not. We are not. We have covered each and every concept related to decimation and interpolation, and you will not face any difficulty in doing so, in doing the questions related to decimation and interpolation. So guys, if you were able to understand it, just hit the subscribe button, and it would be great to know that you were able to understand it. And please do not forget to subscribe us. because it motivates me, it motivates our team in order to make more such videos and able to help the our other fellow college students to ace in their exams. So guys, this is it for this one. See you in the next video.